Hey there! If you're watching this video, I'm assuming it's because you're interested about learning more about hand tools and hardware, and that's great because that's just what we're going to do here. I'm Emily, and I'll be introducing you to some of the most common tools you'll encounter in everyday life. Now, I'm not saying that you'll be equipped for every home improvement scenario after watching this series, but I do feel 100% confident that you'll be capable of tackling IKEA furniture assembly. Before we meet the tools though, I think it's good to lay some groundwork about the principles of mechanics. Basically, most tools are simple or compound machines that transform force. Force is something that acts upon an object to move it. A machine will either multiply or change the direction of force in order to make it easier to move something than it would be to do manually. Renaissance scientists identified 6 classical simple machines: the lever, the wheel and axle, the pulley, the inclined plane, the wedge, and the screw. Some of these can actually be considered derivatives of the others. For example, the wedge is just a portable inclined plane, and the screw is an inclined plane wrapped around a cylinder. As we examine the tools, you'll see how elements of these simple machines appear and transform the force. Let's take a closer look at each of them. First, we have the lever. Archimedes, the ancient Greek mathematician and physicist, famously said, "Give me a lever long enough and a fulcrum on which to place it, and I shall move the world." In its most basic form, the lever works by using a pivot or fulcrum, positioned so that a light amount of force applied to one end of the lever multiplies to a greater amount of force on the other. A good example of this kind of lever, with the fulcrum between the force and the load, is a seesaw. If the fulcrum is exactly in the center of the lever, the input force will equal the output force, but as the fulcrum is moved further from the end of the input force, the output force will increase. A second kind of lever puts the fulcrum at one end and the load in the middle. A wheelbarrow uses this kind of leverage. A third kind of lever puts the effort in the middle, and its primary advantage is multiplying the speed applied to the load. An example of this kind of lever would be a hammer. The more you look, the more you'll see levers everywhere, and you'll begin to appreciate how they make life easier by multiplying force. Next, we have the wheel and axle. The wheel and axle is really a variant of the lever, with the axle being a fixed fulcrum. The outer edge of the wheel covers more distance than the axle while rotating at the same speed, which leads to some interesting properties. This feature may be used to an advantage when rotational force is applied to the axle to accelerate the distance traversed by the wheel, as in a circular saw blade, or it may be used to multiply the rotational force of the axle when force is applied to the outer edge of the wheel, as in a windlass. Wheels and axles can also be used to reduce friction, which is personally one of my favorite applications. Pushing something along in a cart or dolly is significantly easier than dragging it along on the ground. We won't encounter a lot of pulleys in our basic tool collection, but it is a useful thing to know about. Essentially, a pulley is a wheel that reverses the direction of a force by transforming downward motion on one side to upward motion on the other. This can be helpful if you want to use your natural gravity to lift something. Pulleys can also be used in a combination called the block and tackle, which multiplies the downward force, allowing you to lift heavier objects with less effort. The inclined plane distributes the amount of force required to lift an object over a distance. The most basic application of this is a ramp. The total amount of force expended to raise the object is the same, assuming no loss from friction, but because it is distributed over distance, less force is required at a given moment in time. We can see the principle applied in a serpentine path up a mountain. It would be faster to go straight up the mountain, but requires strenuous exertion of energy, so by using switchbacks, we take a longer but less taxing journey. The wedge is a portable inclined plane and transforms a force applied to the blunt end of a force perpendicular to its inclined surfaces. Blades and chisels are types of wedges. An axe would be considered a combination of a wedge and a lever. Wedges can also be used to hold objects in place, such as a shim or a keystone. The friction between the surface area of the wedge and the object it is wedged against locks it in place. The screw uses an inclined plane wound around a cylinder to transform rotational force to directional force. Because of the large amount of surface area in contact with the screw, screws generally involve a lot of friction, which makes them self-locking, meaning that the material that is resisting the screw cannot push the screw back out. This makes them ideal fasteners for a number of applications. So, now that you know some basics about the ways that force can be transformed, let's see if we can recognize them in some tools and hardware. Understanding the underlying principles should help you think of more creative applications for tools, too.